So in 2.5, we're going to talk about some more applications of right triangles. So one of the first things that we're going to talk about has to do with something known as bearing. And bearing is basically used, which we've talked about, in navigation. Okay, and so we can express it as a single number. So when we do it as a single number, we always start at north. Okay, so north be right here. Right, so here's north, and if we think about it, we can almost kind of build right our 90, our 180, or 270. So this would become 0 degrees, and then this would be 90. This would be your 180, and this would be your 270. If we make it all the way back, it'd be a full circle, right? So if I wanted you to draw something with a bearing of, say, 27 degrees. So 27 is between 0 and 9. So what we would do is we would draw our due north, and then 27 degrees is this distance right here. So it's how far away you are from your north line, all right? If I said something like 150, right? So again, I would draw a due north, and then 150 is in this quadrant right here. So I'd probably say it's right about there. So again, it's the distance from my north line to here. If I want to talk about it in terms of two things, right? So what happens if I don't want to do a single number? So I can talk about two directions instead of just one direction. Okay, so two directions. I always start with north or south. Then it comes the acute angle, and then it ends with east or west. Okay, so that's our second way. So if I wanted to draw, say, something that said north by 30 degrees west, okay? So again, here's my north, right, north, and if I think about it, again, down here would be south, down here would be east, and over here would be west. So I'm in between my north and my west. Again, 30 degrees is how far away I am from my north line. So I'd be in this direction right here. Okay. If I wanted to say south by 10 degrees east, again, here's my north line, and I can also draw my south line down here. So here's my south, here's my east, here's my west. So again, I am 10 degrees away from my south line, heading towards east. So this is where my 10 degrees is going to be. Okay, so again, it's a different type of concept, understanding what's happening. Excuse me. Let's take a look at our first problem. So it's a word problem. So it says radar stations A and B are on an east-west line 3.7 kilometers apart. Station A detects a plane at C on a bearing of 61 degrees. Station B detects the same, I forgot the word plane, I wrote just lane, sorry, on the same bearing. Ooh, I did not spell bearing right. Sorry, bearing of 331 degrees. So we want to find the distance from A to C. Okay, so let's go ahead and think about this. Okay, so A and B are on an east-west line. Okay, so I know they're on an east-west line. Okay, and they are 3.7 kilometers apart. So I'm going to put 3.7. Now, I'm not quite sure which one is A and which one is B yet. Okay, but it's safe to say that my plane is at C, and chances are C is going to be somewhere in our middle. Okay, so that's kind of the best bet. All right, so I'm gonna draw a little north over here. I'm gonna put a little north over here. Okay, so if I wanted to draw something to get to this point, okay, I want to draw this little angle right here. This angle, right, can only be one of two. It could either be 61 degrees or 331 degrees. Okay, so remember, you always start at your north, and you kind of work your way around. So if I wanted 331, right, I would be kind of in this quadrant, so I'd be kind of going in that direction. If I only want 61, I'd be in this direction. So it makes more sense that this guy is going to be your 61 degrees, which means that is your A station. Your next station, right, is your B station. So I'm going to call this B. So again, here's my B station, and it makes more sense, right? Because if I was to draw this around, here's 90, here's 180, here's 270. So if I want all the way around from here all the way to here, this makes sense that this is more than 270, so it's 331 degrees. Okay, so that kind of makes a little sense. Okay, so I know that A and B are on the same line because they are on an east-west line. So if this is an east-west line, okay, I know that that runs perpendicular to north and south, which means I know that this altogether is a right triangle. So I want to know, I basically have to figure out though, is A, B, C's triangle a right triangle? That's what I'm trying to figure out right now. Okay, so the first thing I'm going to do is I'm going to figure out what this angle down here is. So I know that altogether angle A should be 90 degrees if I add up this little angle 61 with whatever's inside my triangle. Okay, so on inside of my triangle, if I subtract 90 from 61 degrees, I'm going to be left with 29 degrees. So this guy right here should be 29 degrees. I'm going to do the same thing over here. So I know all the way around, okay, is 29 degrees. So I want to figure out what is the difference between 331 and 270. So I'm going to say 331 minus 270. Track them. I get a little 61 degrees, so this will become 61. And I already know that 29 and 61 add up to 90 degrees based on this information here. So now I know that this is a right triangle. So now that I know it's a right triangle, I can use some trig in order to find my distance. So what am I again trying to find? I'm trying to find the distance from A to C. So I'm going to call that x. Okay. So what do I know? I know the hypotenuse, and I know two of my angles. Okay, and x happens to be a side. So I'm going to use the cosine of 29 degrees, and that is going to equal my A to C line, so x, and then all over 3.7. So again, once I figured out this was a right triangle, I can now use trig. So calculator ready, I can plug this in to a calculator. So 3.7 times cosine of 29. Go ahead, bring up a calculator. So first thing first, make sure we're in the correct mode. I see that we are in degrees. Wonderful. So I'm going to type in 3.7 and then type in cosine and 29 and then close my parentheses. So my distance is about 3.23 as my x. So I'm going to say that my x is about 3.2 kilometers. Okay, and that makes sense. It's smaller than our hypotenuse. Okay, so let's go ahead and try our next problem. Okay, so here's our next problem. A plane flies 1.3 hour at 110 miles per hour on a bearing of 40 degrees. It then turns and flies 1.5 hours at the same speed on a different bearing, which is 130. So how far is the plane from its start point? All right. So let's go ahead and draw what we know. So let's say that this right here is my start point. So here's, again, due north. So I'm going to call this my SP for start point, right? Okay. So it does a bearing of 40 degrees. So 40 degrees would kind of leave me right about here. So it heads up, heads up, it heads up, it heads up, and then it hits a point. Okay. So it travels. So this is, again, 40 degrees. So how long did it actually travel for? So it traveled for 1.3 hours. So we're going to go ahead and we're going to multiply 1.3 by 110. So let's go ahead and do that. Oops. Clear that one more time. 1.3 times 110 gives us 143. So this equals 143 miles. So I'm going to put that right there. So 143 miles. Okay. So then it stops at that point. So I have to draw another little arrow. And it then turns and flies for a bearing of 130 degrees. So 130 degrees, this would be more than 90. So it would probably be right about here. So then it turns and it flies and it flies and it flies and maybe it stops right here. So I'm going to call this the ending point. So EP, ending point. So again, this is 130 degrees. This is where my plane is. So let's go ahead and figure that out. So again, it's still traveling 110 miles per hour. I'm going to multiply that by 1.5 hours. So we get, it's about 165. Excellent. So 165. So 165. So how far is the plane from its start? Okay. So I want to figure what this is. So I'm going to put a little x here. Now, here is a problem. We don't actually know if the start point and the ending point are on an east-west line. So I don't actually know if this angle right here is 50 degrees, okay, because this would be 40 and 40 plus 50. So I don't actually know that, okay, but I have to figure out if this is a right triangle or not. So how do I do that? Okay, that's the tricky part. All right, so let's prove that it's a right triangle. Well, I know that this down here would extend through my northwest, and I know that going from a northwest line is 180. So if I take 180 and I subtract 130, I know that this part right here will be 50. Okay, so this is 50 degrees. Now, these lines are parallel to each other. North and north lines are parallel, which means this angle right here is going to be congruent with this angle right here, which means that this will also be 40. And what do we know about 40 plus 50? That gives us our 90 degrees. So we've figured out that this is, in fact, a right triangle. So again, we have to first prove that it's a right triangle before we can do anything. Now, we cannot use, we're not going to use cosine, sine, because again, I still don't know what this angle down here is, okay? And I can't use really 90 degrees. So what can I do? I can use the Pythagorean theorem. So a squared plus b squared is equal to c squared. So my two legs, so 143 squared plus 165 squared is equal to c squared, And then I'm going to take the square root to both sides, and this will give me my answer. So let's go ahead, let's plug it into my calculator. I'm going to plug it in right away, just the way I see it. So 143 squared plus 165 squared. Now my answer should be larger than 165 since it is the hypotenuse. So I'm going to get 218.34. So 218.34, and I will say miles. That's how far away my plane is from my start point. Again, we're trying to prove that it is a right triangle first. Okay. So our last problem, okay, is going to look something like this. Oh, it's not here. That's okay. I will redraw it. Okay, so it's going to look like this. Here's my lovely triangle. Bam. And I'm actually going to draw a triangle within a triangle. Okay, and I'm going to call this H, and I'm going to call this 36.7 degrees, and I'll call this guy 22.2 degrees, and this from here is 50 to just here. Okay, and what I want us to do is I want us to find H. Okay, so, oh, and this is a right triangle, so I'm going to give you that information. All right, so I know that it's a right triangle. Okay, I need to find H. Okay, my 7 looks bad. I'm going to redraw it here. So that's 0.7. There we go. Okay, so I need to find this guy H. Okay, and I want to use my giant triangle as well. So I'm basically going to build 2 trig equations, okay, to help me figure out what H is. Okay, and what I'm going to need to know is I don't want to use the hypotenuse of my smaller triangle because that's not going to help me with my 22.2 degrees. Okay, so what I'm going to do is I'm actually going to use my leg. Okay, so I'm going to use this little guy. So in my first little triangle, I'm going to say that the tangent of 36.7 degrees is equal to opposite, which is h, all over hypotenuse, which I just labeled as an x. Okay, so it's one equation but with 2 variables. Well, if we remember our time from previous math classes, if I have 2 variables, I can come up with 2 equations. So what I can do is I can build a second triangle, and I'm going to say my second triangle's base, right, is all of this, which means that this would be 50 plus x. My height is still h, but I have a new degree, so I'm going to say tangent of 22.2 is equal to opposite, which would be h, all over my denominator of 50 plus h. All right, so 2 equations, 2 different variables I need to solve for. I really just, again, still need to solve for h, but again, we have to do a little bit of work in order to do that. So let's take a look at our blue equation. If I multiply both sides by x, I can at least isolate my h. And then I can use my system of equations where I can plug this bad boy in to my second equation right here. So I'm going to plug it in. And again, I'm going to try to color coordinate it for you. So this is going to become tangent of 22.2. My numerator is now x times the tangent of 36.7. And my denominator is 50 plus x. So now what I have to do is I have to get my 50 plus x out of my denominator. So let's go ahead and I'm going to multiply 50 plus x, 50 plus x to the both sides. Now, if you remember from logs, right, remember we had to kind of distribute our logs to everything. We're going to do the same thing here. We have to distribute the tan to everything. So I'm going to say that this is 50 times the tangent of 22.2 degrees plus x times the tangent of 22.2 degrees is equal to, and again, I'm still going to try to color coordinate this, x times the tangent of 36 plus 7.7. I can then move my x over to the other side. So 50 tangent 22.2 is equal to, and then this will become x tangent of 36.7 minus x tangent 22.2 degrees. Now, what do they both have in common? They both have an x, so let's factor it out. All right, I'm going to stop color coordinating it now. All right, so on the left side, everything stays the same. Right side, the x is pulled out, while the tangents stay underneath. So that means that if I divide this by my tangent, it should just equal my x. So let's go ahead, let's plug that into our calculator. And we have to be careful when we use this. We have to use parentheses. So parentheses, 50 tan 22.2, close my parentheses, so double parentheses, divide by, open parentheses, tangent 36.7, oops, hold on, delete, 36.7, there we go, and then minus my tangent 22.2, close. So this should give us 60.49. All right, so this little guy right here is 60.49. So x is 60.49. But I don't want to find x. What I want to find is h. But the great news is, what I can do is I can come up here and I can use this guy right here to find my h. So I'll go ahead and I'll say that this is 60.49 times my tangent of 36.7. So let's go ahead and say, let me move it out of the way so we can still see what we're doing. So 60.49 times my tangent of 36.7. Close and enter. So my height is about 45.087, so I would say 45.09. So my height is 40, hold on, 45, thank you, 45.09. Now I didn't talk about if it's like feet or inches, it's just units. And that's it, okay? So again, kind of different problems. Again, they're all right triangles, so we're going to either use trig like we did on this example, or we did on our radar problem, or we're going to use Pythagorean theorem, right, to find our missing value, okay? So that's our 3 problems. Good luck.